So on this first one, 3 3/4 plus 6 5/8, we need a common denominator. And what is that common denominator going to be? Just eighths. So the 5/8 isn't going to change. 3/4 becomes how many eighths? 6. Good. So now we add 6 plus 5 is 11/8, which of course is improper. So that's 1 3/8. So we'll keep the 3/8 and carry the 1. 1 3 is 4, plus 6 is 10. So that is 10 3/8 for number 1.
So I got a question.
Yeah.
I got the same answer, but I went about it a different way. I went
Made them improper.
Plus 3, and then 6 times 8
Yep.
plus 5.
But that'll work every time. It's a little bit more work, but it will work every time. Yep. Now here, 8 1/5 minus the 5 5/6. We need a common denominator again, which is going to be what? 30. Good. What's this going to become? 6. Good. 5 times 6 to make 30. 1 times 6 is 6. What'll this be? 25. Now we have to borrow because we can't do 6/30 minus 5, 25/30. So this is going to be 7. What's this become? 36. Remember, we've borrowed one whole object, and it's always the denominator that tells us how many pieces are in it. So we always have to add the denominator to our numerator when we borrow. So 36/30 minus 25/30 is 11/30. 7 minus 5 is 2. So 2 11/30. Any questions? Okay. And that's the problem with making them into improper fractions. You're dealing with larger numbers. You're adding a couple of steps, and then you're dealing with larger numbers, so the chances of making an error there is a little bit greater.
This makes more sense to make them improper first.
For you, sure. Instead of trying to work with them as two pieces.
Can you go through number 2 doing the improper?
Sure. So 8 times 5 is 40, plus 1 is 41/5. 5 times 6 is 30, plus 5 is 35/6. Common denominator is going to be 30. So this is going to be 41 times 6 is 246 over 30. 35 times 5 is 175 over 30. So 246 minus 175, of course it's going to be 30th, is 71. And then 30 goes into 71 twice with 11 left over. So for number 3 and 4, when we're multiplying or dividing, we must turn them into improper fractions. So 2 1/2 becomes how many halves? 5 halves. 3 1/5 becomes 16/5. Now, before we multiply here, what can we do? We can simplify, reduce, cross cancel. The 5's divided by 5, give me 1 and 1. 2 and 16 can both divide by 2 to give me 1 and 8. And all that's left there is 1 times 8 is 8. 1 times 1 is 1. So 8 over 1 is just 8. Any questions? So for number 4, to divide, we have to start out by making them improper again. 7 2/3 becomes how many thirds? 23. Very good. Now we're still dividing yet. 7 1/8 becomes how many eighths? 17/8. And now we do 23/3. Stays the same. It's going to be times 8 over 17. 23 times 8 is 184. And 3 times 17 is 51. So then 51 goes into 184 3 times with 31 left over. So 3 and 31 51s. Any questions so far? Now, before I do 5 and 6, I want to do a little bit of a side note here. Move these down out of the way here a bit. All the problems we've done, 1 through 4, can be done on your calculator. I had mentioned to you, most of you, if you have the Texas Instruments calculator, have an ABC key on there. So you could have entered, for example, this is fifths here, 2 1/2 times 3 1/5. That ABC key allows you to enter mixed numbers as well as fractions. So what you would enter in, you would enter 2, for 2 1/2, you'd enter the 2. You would press that ABC key. You'd press 1, press the ABC key again, and press 2. What you've just entered is 2 1/2. Then you would do times. For 3 1/5, it's the same thing. 3, you press ABC. 1, press ABC. And 5, that's entering the 3 1/5. If you hit equals, your calculator should spit out 8. How many of you have a fraction calculator? One of you? Okay. If you try that and you can't get it to work, let me know and I will go through you individually on your calculator, because if you have a Sharp or a Casio, it'll work slightly different. If you have the most recent version of the TI-30, it's a little bit different. The TI-30 math type version is a little bit different. But let me know and I'd be happy to go through those examples with you to help you figure out how your calculator works. So on to 5 and 6. 5 and 6, we're throwing in the variables. Number 5 is just multiplication. So we're going to separate out the numbers. So 8 over 11, 7 over 20. Can I reduce anything? Yes, the 8 and the 20 both divide by 4. So 8 divided by 4? 2. 5. 20 divided by 4? Is 5. So then we have 2 times 7 is 14. And 11 times 5 is 55. So the numerical portion of our answer is going to be 14 over 55. So now we just have to figure out the variables. So I'm going to pull out the variables. We've got x to the 5th over y. And we got y to the 3rd over x to the 3rd. And I usually multiply them out, but you really don't have to. You can actually simplify it from right here. But I'll do x to the 5th, y to the 3rd over x to the 3rd y. So now the x is going to go where? Top or bottom? Top, because the larger power is on top. And it'll have a power of 2. 5 was the bigger power. 5 minus 3 is 2. Where's the y going to go? Top or bottom? Top. And it'll have a power of 2. Good, because 3 minus 1 is 2. So 14x squared, y squared, all over 55. Any questions there? Okay, for number 6. We are subtracting, which means we must have a common denominator. So let's do this in 2 parts. For the numbers 8 and 6, what would the common denominator be? 24. So we know the number is going to be 24. Then we take each variable. So we've got an x. What is the largest power on x? X squared. So it has to have x squared in our common denominator. How about for y? Just y. There's no y here at all. So the highest power is just y. So I'm going to pause for a second. Any questions on where I got the 24x squared y? So we just had the numbers. 8 and 6 gave us the 24. And then the highest power on the variable. So like if we have 8xy. If you factor 8, that's 2 times 2 times 2, and then x times x and y. The 6x squared, if you factor 6, that's 2 times 3, and then x squared is just x times x. If If you look at them, they both have a 2, and they both have an x. That's all they have in common. The top one needs a 3 and another x. So now we've got those in common. The bottom one needs 2 2's and another y. So what we have here is we have, this is 6x squared times 2 is 12 times 2 is 24 times y, so it's x squared, 24x squared y. Same here, this is 8xy times 3 is 24 times x is x squared y. So it is 24x squared y. So if you ever get totally stumped, you can always factor them out and just make sure they both have all the same factors. Multiply in the factors that are missing if you have to. So now, what do we have to multiply the 8x squared by to make it into a 24x squared, or the 8xy by to make it into a 24x squared y? 3 and then x, good. 8 times 3 to make the 24, and x times x to make the x squared. So the 5 for the numerator has to also be multiplied by 3x, which would give us 15x. Down here, what did we have to multiply? Well, the 6 has to multiply by 4. Do we have to do anything to the x? Nope, it's already an x squared. But we do need a y. So we have to multiply by y. So we have to multiply by 4y. So 3 has to also be multiplied by 4y, which will give us 12y. And now we are subtracting. So we have the common denominator, so we're just going to combine the counts. 15x minus 12y is 15x minus 12y. All over 24x squared y. Look familiar? Okay.
I always try and, like, with 15x minus 12y, I always try and do
Try to combine them.
15 minus 12 and just put xy.
Yep. You got to be careful. Unless they start with the same name, you cannot combine them when you add or subtract.
For multiplication,
Multiplication, yeah, you combine pretty much anything.
I just put xy at the
Yep.
end.
Yep. Yeah, if you have 7x plus 5y, your answer is just 7x plus 5y. If you have 7x times 5y, 7 times 5 is 35, x times y is xy. Okay. So today's new topic might look something like this. This is simply an order of operations problem. And all it's asking us to do is to follow the order of operations. This is a fraction bar, and it is telling us to divide. But before we divide, what do we have to do? We have to do what's on top. So here that's 1 3/5 times 3/4. So how do we do 1 3/5 times 3/4? Make it improper. So 1 3/5 becomes 8/5. Good. 1 times 5 is 5 plus 3 is 8. 3/4, of course, is a fraction, so it doesn't need to be changed. Then what? Cross cancel. The 8 and 4 will both divide by 4, giving me 1 and 2. 2 times 3 is 6. 5 times 1 is 5. So I got 6/5. I know I can reduce that to 1 1/5. But I'm going to wait right now because I know that this fraction bar means I'm going to have to divide that by something.
With that, can you also multiply across? And just reduce
You could have done 8 times 3 is 24, and 5 times 4 is 20, and then divide both by 4. Give you 6/5.
You can do that every time. And
Yep, you can do that every time.
everything's the wrong way.
Yep.
I don't know.
And that's fine. Like I said, it's just a few more steps because you're working with bigger numbers, but that is absolutely fine. That'll work every time. And like I said, we've got an improper fraction here, but we're going to leave that because we're going to need to divide that number. So 2/3 and 1/6. We're adding those, so how do we add 2/3 and 1/6? Common denominator, which will be 6. So this is 1/6, yet 2/3 becomes 4/6, which adds up to be 5/6. So this is 6/5 divided by 5/6. What do we do next? Yeah, it's always easier to me if I write it like this first. 6/5 divided by 5/6. Can I cross cancel? Not right now I can't because it is still division. Before I can cross cancel, I have to make it multiplication. So this is 6/5 and it'll become times 6/5. So 6 times 6 is 36. 5 times 5, 25. 25 goes into 36 once with 11 left over. So 1 and 11/25. That's the answer. So let's look at something like this. Again, this is order of operations. We have to do what's in the parentheses first. 5/8 plus 1/6. Now I'm going to do it off on the side here, because we have to go through the process of finding that common denominator, which will be 24. This is going to become 15, good. 8 times 3, so 5 times 3. This will be 4. 6 times 4, so 1 times 4 is 4. And we add. 15 plus 1 is 19/24. That's it. There's nothing we can reduce that, so that is 19/24 here in the parentheses. We've reduced what's in the parentheses to a single number, a single fraction, so we get rid of the parentheses. This is now 2/3 times 19/24 minus the 1/2. What's the next step? We have to multiply. Now you could multiply 2 times 19 is 38 and 3 times 24 is 72. But we can reduce here the 2 and the 24, so I'm going to do that. Both divided by 2, so they give me 12 and 1. So 1 times 19 is 19. 3 times 12 is 36. So I replace the 2/3 times 19/24 with 19/36. Then what? We have to subtract the 1/2. So again, I'm going to set this up. 19/36 minus 1/2. Common denominator will be 36. So it stays 19/36. 1/2 is going to become how many 36? 18/36. Very good. So 19 minus 18 is 1/36. So that equals 1/36. Not so bad? What's that? It is. It's a pain. Since we're having fun with it, you know me better than that by now. Something like this. Where do we start? Yeah, we have to start on the top, of course. The fraction bar says do everything on top. And on top, we do have the parentheses to do first. 2 1/8 minus 1 1/4. What is our common denominator going to be? 8. So this stays 2 1/8. This becomes 1 2/8. So when we go to subtract, 1/8 minus 2/8 can't be done, so we borrow. This is 1. What's this become? 9. Because we have to add the denominator to our numerator. We borrowed 1. That denominator tells us that's 8 pieces. So 1 plus 8 is 9. 9 minus 2 is 7/8. 1 minus 1 is gone. It's nothing. So this is now 7/8 here in the parentheses. So that now has become 1 1/2 minus 2/3 times, we don't need the parentheses anymore, times the 7/8. Now what? Two thirds times 7/8, and we can cross cancel the 2 and 8 to give me 4 and 1. 1 times 7 is 7. 3 times 4 is 12. So I have 1 1/2 minus 7/12. So we do have to have a common denominator, which is going to be 12. So 1/2 is how many twelfths? 6. Right? So we've got the 6/12 minus the 7/12 can't be done. So I'm going to borrow from the 1. That's a 0. This will become 18. 6 plus 12 is 18. 18 minus 17 is 11/12. So the top of this has become 11/12. So now we have to do the bottom. What do we have to do first on the bottom down here? We have to multiply. 1 1/5 times 1 2/3. You first must make them improper. 1 1/5 will be 6/5. 1 2/3. 5/3. Well, we cross cancel here. The 5 and 5 cross cancel to give us 1 and 1. 6 and 3 cross cancel to give me 1 and 2 or 2 and 1. Yep. 2 times 1 is 2. 1 times 1 is 1. So it's 2 over 1 or just 2. So I have 3 and 1/2 minus 2, which is 1 and 1/2. We subtract the 2 from the 3. There's nothing to affect the fraction. That's 1 1/2. So we now have 11/12 divided by 1 1/2. So I'm going to write that out down here. 11/12 divided by 1 1/2. What do we do next? Okay, the 11/12 won't change. The 1 1/2 becomes an improper fraction, which will be how many halves? 3 over 2. Can we cross cancel the 3 and the 12? No, because it's division yet. Our next step, we're going to make it into multiplying. So the 11/12 stays the same. It becomes times 2 over 3. Now we can cross cancel the 12 and 2 to give me a 1 and 6. So 11 times 1 is 11. 6 times 3 is 18. 11/18. What do you think? Loads of fun? So what if I give you a problem that looks like this? What does that mean? What's that? Not so much, not necessarily. It makes more sense if I write it like this. 7x to the third over 8y divided by 21x over 32y. Bless you. Now it looks more familiar to us. The 7x to the third over 8y is not going to change. This is going to become times 32y over 21x. And now I generally will pull out the numbers. 7/8 times 32 over 21. And like you were saying, you could multiply them out and reduce if you want to. Or we can reduce first. 7 and 21 both divide by 7. Gives me 1 and 3. 8 and 32 both divide by 8. Gives me 1 and 4.
You only cancel out like that when the two numbers that are across or diagonal from each other.
It has to be one number on top and one number on bottom. So when you're dealing with two fractions like this, if they were both in the same fraction, you could have reduced the fraction to begin with. So usually you won't have that. So generally it is going to be diagonal.
Right, but like say it's 7 and 22 or something.
They have to divide by the same number. So 7 and 22 have no common factors. So there's nothing that divides both of them. Good question though. So we end up with 4 over 3. We cannot make that 1 1/3, so we're going to leave it as 4 over 3. Remember, there's variables involved, so we never make it never make it into a mixed number. So now with the variables, we got x to the third over y. We've got y over x. Again, I could probably just deal with them just like that, but we're going to multiply them out. So this is x to the third y over xy. What happens to the x? On top, power of 2. Good. Because that's x to the third, and if you think of that as x to the 1, 3 minus 1 is 2. What happens to the y? Y's cancel out. That's just 4x squared over 3. Any questions? Okay. So there is that new quiz that is due today. So that is tonight at 11:59 p.m. There is new homework due for Monday. And let's see, we have to be approaching our Unit 2 test. Let me take a peek here. I was gonna say it's got to be coming up, I think, the week after, next week at some point. And yes, it is next week, Thursday. So yes, next week, Thursday, we have it scheduled. So Monday next week, we'll be going over new material yet. Wednesday of next week, we'll be kind of wrapping up and reviewing everything. So yes, next week, Thursday.
A mock test of what you're going to put on it? Like, that we can just work through?
I don't do that partly because the temptation when you do that is just to make the same test and change the numbers. And the problem that I see with that is people, they memorize the type of problem. They don't really understand what they're doing. They just memorize that type of problem. So when they see it on the test, they just change the numbers and do it. I have done that for other classes, but it's painstaking because I have to go through and say, okay, these are the concepts covered. So I have to come up with a problem that covers that same concept, but it looks different from the problem that's on the test. So you can't just memorize, oh, that's this problem.
So can you go over so we can write down,
But
like,
what I do is,
ones?
like next week, Wednesday, I will do a review in class where I will do a problem that covers every concept that is on the test. So next Wednesday, we will do a review in class.
No word problems, right?
Unfortunately, there are some word problems. This one, though, I believe is fewer word problems than the last one, if I remember correctly. Just because of the nature of the material. I don't have that one in here. Let's look here. This one has only like 5 or 6 word problems instead of 7 or 8 like the last one did. You'll get used to them. I mean, you're going to probably have to go on and take business math next.
I
So
was going to say, I heard the business math has a lot of word problems.
business math is mostly word problems.
So do you use much algebra for that one, or?
You know, there's probably more algebra in this class than there is in business math, to be honest with you.